Get started.
Cool.
All right, so you have to help me out here a little bit. Have you guys studied absolute value?
Yes, we have.
You have. Now, have you studied it with inequalities? So like the absolute value of X is less than or equal to 5, for example. Is that something you've seen before?
We've never done the multiplying on the left side.
With the absolute value.
Yeah, well,
This
it would
absolute
just
value.
be, it would, oh, I thought those were ones, my bad. Yeah, so it would just be X. Yeah, we've done that before.
So, well, my guess is you've done this. The absolute value of X equals 5. So you've got like X is either 5 or -5, something like that.
Yeah,
Okay, and you might have even done, some more complicated ones like 2 times absolute value of X minus 3 equals to I'll say 7,
yeah.
something like that.
Mhm.
Or that's a bad example here. Let's do 8. Okay. So here
Okay.
you would divide by 2. You'd have the absolute value of X minus 3 equals 4. And this produces like a case 1 and case 2. So I think you've said you've seen that X minus 3 equals 4.
Mhm.
X minus 3 equals -4. Is that right?
Yep.
Okay. Plus 3, plus 3, plus 3. X equals 7. X equals -1. Okay, that's good.
I do have one question.
Yeah.
I thought when it's absolute value, the negative sign changes into a positive.
The absolute value equaling a number. The case 1
Okay.
is the number. Case 2 is the negative of the number.
I see.
What you're referring to, which is correct, is if I give you the absolute value of 3, that's 3. Or if I ask you the absolute value of -3, that's
Right.
also 3.
-3. Right.
So it always returns positive, but in terms of solving, you set one equal to positive, one equal to negative. So let me just give you a couple of these to try here before we move on to inequalities. You can just think of this as like, the warm-up practice for the other stuff today, and then we'll get to that. All right, so here, just start you out with the one that's not too bad, and then increase the difficulty from here. So you got a notebook out, some pencil and paper, hopefully.
Yeah, I'm ready.
Great. All right, so go ahead and solve this. It does have 2 solutions, please.
N equals -7, N equals -9.
Yes, those are correct. Very good. All right, so give you one that's a little bit more difficult here to think about, work out. I do believe that you've seen this before, but it's just practice. Just try a couple more of these.
Okay, I have. Hold on,
Go
let me
ahead.
make sure that this. I have n equals 3/2 and n equals -3/6/8.
Okay.
I did
The
some, I divided by 8 when I got,
you have to subtract 10 from both sides first.
right, yeah, I did that.
Okay, so do you have 8n equals -32?
32, yeah, I
Okay,
have that.
now on the left here, when you divide by 8, I agree with what you said. You said n equals 3/2.
Yeah,
Okay, on the right here though, this works out nicely. This meaning it divides unevenly.
oh, is that just 4?
Yes,
-4?
-4.
Oh, I don't know why I made that. I thought that was a brain part. Yeah.
That's
8,
okay.
16, 24, 32. Yeah, that makes sense.
We got plenty of time here. You know, there's nothing urgent right now. Maybe you've heard of that you know, you've heard of things like urgent versus important. Like if you're driving down the side of the road and you get a flat tire, that's urgent and important. What we're doing right now is just important. It's important that you know how to solve these, but it's not urgent. So don't feel like you need to rush through any of these. The goal is just to get you to get familiar with these for the absolute value and equality stuff, which is a little bit more of a pain to deal with.
Yeah.
So,
Should I try this one?
yeah, go ahead and try this one. Let me know what you come up with.
If my n is a negative, does that matter?
It needs to be positive, so you're gonna have to
Right.
have to
I have
multiply by
get to
negative.
the other side or multiply it by itself.
Yes.
Okay. All right. I have n equals -5, n equals -1.
Okay. Now here's one way we can check it, which we haven't done yet. Let's check it for n equals -5. So we
Okay.
have -3 minus a -5. Notice I'm substituting in parentheses. The subtraction is still the subtraction, but the n is what I'm saying is in parentheses. Okay.
Right.
You distribute the negative. So it's -3 plus 5 absolute value. Now there's really these implied parentheses inside here. It's like do everything inside parentheses until you get just a number.
Right.
Then you take the absolute value. Absolute value of 2 is 2. So great, that one worked. Next one for -1, -3 minus a -1, absolute value. -3 plus 1 is -2. Yes, they both work.
All right. Perfect.
Good. Okay, so I'll give you just a tiny bit more difficult one, and then we'll move to some inequality stuff here. Well, I mean, I should probably do a little bit more on this, but here's one for you to look at. All right, here we go. Give that a try, please. If you got some questions, please ask.
All right. On this, I got x equals 11, x equals -9.
And those are both perfect. Okay. All right. So let's look at some inequality stuff here. Okay.
Okay.
So let me just pose a question here, or pose the problem, and then we're going to talk about like what this means. Okay. So this says the absolute value of x is less than 3. Okay.
Okay.
This means that there's numbers that when you take the absolute value of them, they are less than 3. So could you give me an example of a number that is less than 3?
1.
1. Is the absolute value of 1 less than 3?
Yes.
Yes. How about -1? Does that also work?
No.
What is
Wait,
the
yeah.
absolute the
Yeah.
absolute value of it does,
'Cause
right?
that's 1.
That's 1. 1 is less than 3. Yes, that works. Okay. So there's a formula for this. Okay. So when you see a problem of this form, basically, if you see the absolute value of x less than a number, I'm going to call that C, you do the following. You bring the x down without the absolute value, you bring the less than down, and you bring the number down. This is where there's a little bit extra. So the extra stuff I'm going to put in red here, you write the same inequality and the negative of that number.
Okay.
Okay, so now let's look at yours. What would that do here? You would have x less than 3, and then over here you'd have -3 on the left. And this says it's all the numbers between -3 and +3.
Right.
Okay.
I get that.
All right. So not too bad. Let's give you one here to look at together. Get another example here. So if it's less than or equal to, what you do is you bring whatever's inside the absolute value down, bring the inequality down, bring the 8 down, okay, or whatever that number is, and then you repeat. So you put the less than or equal to on the left here with the negative of that number there on
Negative.
the left.
And right.
Okay. All right. So now you might think I've got it, right? How could this be so difficult? Well, here's the third problem. This worksheet actually has nice incremental order here to this. So you bring the whatever's inside absolute value, the 2x down.
Oh, I see what it's.
Bring the less than down. Bring the negative number down. Do not try to solve it until you write it in this form.
Okay.
Then you have to manipulate this just like we were doing.
Mhm.
Okay. So basically the absolute value adds just another layer to what you've already been doing. You write this and now you have to solve it. You solve by dividing both sides by 2. -3 less than x less than 3.
Got it.
Okay. So if you think you got that down, I think you do. Here's one for you to try on your own. I'm going to leave it up with this other problem in case you want to look at it. But go ahead and solve this for me and let me know what you come up with.
Should I reduce these or like when I'm dividing?
There should be no division on this one because it's x plus 3 less than 4. And then on the left here, -4.
Oh,
Should be
you keep the x plus 3? I thought you make it 3x.
no. So that's good. So
Oh,
it's
that's
whatever
the difference between these two?
it's whatever's inside the absolute value you just bring down without the absolute value.
Got it. All right, I got that written down.
Okay. What do you got for your solutions?
Wait, hold on. I didn't do my solutions part. I just had what you had down. I'll get that right now. -7 is less than x less than -1.
Positive one.
Positive 1.
This one. Okay. So this is where your teacher might say, is 3 a solution? And you would say,
Yes,
yes, it is.
because it's
If
in
it's
between these two.
if it's but it's not. Sorry, I let you talked me into that.
Oh wait, it's not.
It is not. There's -7, there's 1. There's all the numbers between them, and there's 3.
Oh, wait, yeah, that wouldn't be.
Yeah.
Okay. Something like -1 or -2 would be.
Exactly. Yeah, good. Very good. Okay.
And when they ask for, so on the test, I'm
Yes.
pretty sure I'm almost positive I got this right, but I just want to make sure. So he asked, just keep in mind like the number line, and we had the number line written out. And then problem C was, can you plug in 2 more points and prove that they're true? So I think it was between like -1 and +2. And I plugged in, I think 0 and 1 to show that those were true.
As long as they're between there, they are
Yeah,
correct.
and then I plugged those in, and yeah, all right, got it.
Great. All right, so here's another problem for you to work on. Then we'll increase the difficulty a little bit.
Oh, wait. 4 is less than x less than 10.
Like this.
Yeah.
So let's just say we wanted to try like 5. We think 5 works, right?
Okay.
And maybe pick like 9.
Yeah.
You know, this isn't a full-blown check. It's like, well, maybe it works, but you can always like try some of these answers back in the original. It's like just to give you some confidence, but it is very, very much the same as what we've been doing here. You rewrite it, you add 7, and you got it. 4 less than x less than 10. Okay.
All right. Yep.
All right. So here's we'll just increase the difficulty just a tiny bit here. Just to see where you're at on some of these. But here's a new problem for you to look at. Basically, you're just going to increase the amount of work you do to solve for x.
The final. Yeah.
Yeah, so go ahead and try this one. This one does have some fractions, but I think you'll be able to manage.
And just to be clear, the -2 would go on the left side in this case, right?
It's always that number on the right. Whatever. So this number. So another way to see this, what some students do is it's 9 and -9, and then the symbol comes, and then 3x minus 2 between them.
Right.
The number on the left and the right is the same. It comes from the right side.
Two and 1/3 is less than x less than 3 2/3.
So is your teacher asking you to use mixed numbers?
That's how we usually write it out. Yeah.
Okay. I asked because there is a point where you stop writing mixed numbers and you just leave them as improper fractions.
Yeah, he usually has us like fully solve them out, but that's what I had before I fully solved.
Yeah. So like this is where most textbooks will stop right here. And
That's
kind of
a fine answer.
Yeah, and what you're doing is correct. It's just that at some point the preference is for this. So,
Gotcha.
okay. Oh, here we go. Here's one more, and then we got to try. Then we got to switch cases basically, and it gets a lot worse. But let's have you do one more of these. Some works out kind of nice.
Wait, just so I know that I have this like written out right before I try to solve it, is it 9 is less than or equal to, or -9 is less than or equal to 3 plus x minus 1 less than or equal to 9?
Okay. So let me give you some guidance here. I probably should have said a few more things. You have to just get the absolute value before you break it apart. Like you can't have a number in front. You can't be adding or subtracting. So what that means is like, this is your goal,
Mhm.
but to get there, you first subtract 1 from both sides, and then you divide by 2 on both sides.
Got
So
it.
what you can never do is you can never move anything into the absolute value.
Right. Yeah.
You can move stuff out, which maybe you didn't know or it didn't need to know, but this is now a much,
Much easier.
yeah, because it's like, you know,
-3 is less than or equal to x less than or equal to 5.
good. Okay, now real quick before I give you some new problems here, when does the inequality change? What causes, this in the problems we've
The
been,
division of a dividing by negative.
or multiplying by a positive, right? Either one of those will cause it to flip essentially. Okay, so think about that as you work through this problem. I wouldn't tell you about this if it didn't come up basically in the next problem, so keep that in mind. Your goal is to, again, isolate this absolute value x minus 2, which means you need to undo the 10 and then the minus 3.
Got it. Yep. -1 is less than or equal to x less than or equal to 5.
Okay, looking pretty good here. So did you get absolute value x minus 2 less than or equal to 2?
Yep.
Okay, so, when you break this apart, it becomes -2.
Wait, no. I got,
Okay, let's just
instead
step through.
of -6 over -3 and writing 2, I wrote -3. I'm not sure why, but yeah, that it should be Hold on, let me resolve it.
Yeah,
Give
go
me
ahead and resolve it.
Yeah.
I'll throw up a few steps here in case you need them.
So now it's just. Is it 0 is less than or equal to x less than or equal to 4?
Yeah, very good.
Yeah, that was a brain fart on making it not 2 and then
It's
negative
okay.
on both sides. But yeah, I got it.
Yeah, you can see that every little piece has
Yeah.
got to be right, or it, the puzzle doesn't get put back together quite right.
Exactly.
All right. Let me give you one more of these to try, and then we will actually move on to the next case. This one's okay as is. No. 3 minus 2 absolute value x minus 5 is greater than minus 15. Okay, so go ahead and try this for us, please.
-4 is less than x less than 14.
That is correct. Good. Well done. So you should feel real good about where we're at here in the lesson. We've been solving, if we can create a general category of, okay, absolute value inequalities. Okay, and we've gone down this left branch of what to do when you see a less than or a less than or equal to. Okay, everything we just did for the last, minus some time at the beginning was down this branch. Okay, now we're going down the branch of what do you do if it's a greater than or you get a greater than or equal to? These are different. These are not the same.
Okay.
Okay, like I don't know if you switch hit in baseball or
Yeah, I don't,
think,
but
something in life where you literally you change your thinking altogether. Okay, the stuff that worked over here doesn't necessarily work here. Maybe there's some overlap, but not a ton, and that's where students get confused. So you have to do enough of these where you're like, okay, I got it. All right, so here we go. Let's look at an example problem here. A couple of examples for you to think about, look at. So this time, here's the symbol. And just to be clear here, this whole less than or equal to, greater than or equal to, it applies when you've got the absolute value alone. It's not from the beginning. It's when you get here to this point. Okay. All right. So here's what you do. You write exactly what's written, just like you did before. This part is the same. So notice you bring bring what's inside the absolute value down, the inequality down. Okay, but then you write the word or. Does that look familiar? You seen, remember
The
we were
or
doing that?
does look familiar, and then
And then now it's x plus 1. You flip the inequality and you negate it.
yes, this does look familiar.
Okay, so there's two things you do over here. You flip the inequality, and 2, you negate it. Okay, and now you solve it just the way you've been doing. You subtract 1 from both sides, you have x greater than 1. Subtract 1 from both sides, you have x less than -2. But it's an or. It's an or situation. You were doing compound inequalities a while back, or maybe part of this last unit. Or means either one could be true. So if you go to a number line, here's 1, here's -2. X could be greater than 1, that's to the right of 1. X could be less than -2, that's to the left of -2.
Right.
And we didn't graph, we graphed like the first one of the other case. The other case was actually, these are all ands, and these are all ors. These are between,
Between, yeah, okay,
and these are outside.
got it. So when it's greater than these two shaded lines will never, they'll never touch. They're going opposite directions.
That's right. That's right.
Got it.
Okay. So if you feel like you understand that, I think you do. Here, let me
Yeah.
give you one to try. You know, it's all about being comfortable with the setup. Okay, this one is n minus 6 greater than 12. Okay. Tell me the first thing you will write, and I could scroll up if you need me to for the previous example.
Or.
Yeah, there's an or. So what's
and
the
then
one?
and then flip the sign.
Well, like maybe we're just thinking differently right now. I like to just immediately write what's there without the absolute value.
All right,
That's
okay,
the first one.
yeah.
And then then you flip the inequality
And negate it.
and negate it. You have to solve these.
Got it. Do I put these on a line or just tell you?
Just give me your answers whenever you got them.
N is greater than 18 or N is less than -6.
Yes.
Cool.
All right, so let me look for a few more here for you to think about. Okay, I don't. All right, here we go. Here's one for you to try. All right, so go ahead and try this one, please.
X is greater than 5 or X is less than -61/9?
Okay, so the first one is correct. First one is really good. 8 plus 9x greater than 53. You subtract 8, you probably get
45.
yeah, x greater than
Yeah.
45. Now the other one is you write the same thing, but now you flip the inequality and negate it.
-53.
And
And
you
then I subtracted 8.
okay, no, you know what? You are right. I was looking at the solution here, and I thought that this worked out, but it does not. So your answer is correct. So I
So
apologize.
it's fine leaving it like that?
Yeah, I don't know. When I looked at the solution, it looked like it was a whole number, and that's why I was like, oh, maybe made a sign error or something. No, this is really good.
Okay.
This is really good. Okay, so the question here is like, do you feel like you understand this case? You know, this case where it's a greater than or greater than or equal to now like really make them more difficult, or should we do a few more like this? And that's kind of what I'm thinking right now. I was like, well, yeah, like here, let me throw up a problem for you, and you can. I want you to talk.
Let's do some more. I like these. We can go in any direction. I don't really care. I feel comfortable doing these stuff.
Okay, so let me throw something in front of you that like probably haven't looked at this today, but you still do know enough to be able to solve something like this. There's not a gap here in terms of like, you know, you haven't seen this set up. Like I talked about, before you can decide which branch you're going down, before you can decide if you're going left or going right, you have to solve for the absolute value. Meaning like there can't be a number added, there can't be a number in front. So before you can make the decision, you first have to subtract 5 here.
Okay.
So absolute value m/2 greater than or equal to 1. And from here, now you can make that decision. Now you can say, okay, it's the one where I got to write the or.
But now you have to negate it, or
No. What I'm saying is like in all the previous problems, it was already solved for the absolute value. Already solved for the absolute value. You have to make this one additional step here to solve for the absolute value. And then you can do what we've been doing. You can write m/2 greater than or equal to 1, m/2 less than or equal to -1.
the M part is what's confusing me. I don't really understand that part.
It's
What
just
is that?
it's just a variable.
It's just a variable.
There's it's 1/2 times the variable.
Okay. And now then, what are you asking to do? Are you we should
Well, okay,
make
so
it 2/1?
you want to clear it out by multiplying each side by 2.
Right. Multiplied by 2. 2.
It is 2. And then you multiply both sides by 2.
So then you get -2.
Times 2 times 2. So now m is less than or equal to, or m, yeah, sorry, m is less than or equal to -2. Good. All right, so let me give you another one here. Actually, let me make this one up. That one's not going to work. It's too easy. Here's another one for you to look at, kind of in the same scenario here. So let's go. Absolute value x plus 3 plus 7 is greater than or equal to negative. Sorry, that's not going to work. It's equal to 20. Greater than or equal to 20.
All right, I got it. I can first subtract -7, right? I don't have to.
Yeah, you have to. You,
Yeah, I
you
have
cannot you cannot proceed until you isolate the absolute
That's my
value.
first step. Got it. X is greater than or equal to 10 or X is less than or equal to negative 16.
Yes, you got X plus 3. I'll just write it out in case you want to look at this later. X plus 3 less than or equal to negative 13. So X greater than or equal to 10, X less than or equal to negative 16. All right,
Got
good. Okay, a couple more here. All right, let's go 3 absolute value X plus 5 greater than or equal to, oops, let me add in one more thing here. Plus 1 greater than or equal to 10.
All right, got it. X is greater than or equal to -2. X is less than or equal to -8.
Yeah, that actually sounds really good. We'll just work this out. Or did you get absolute value X plus 5 less than or equal, I'm sorry, greater than or equal to 3 to start out? And then X
Yeah.
plus 5 greater than or equal to 3, X plus 5. And I'm really bad about this. I should have been writing or all along less than or equal to -3. Subtract 5, subtract 5, subtract 5, subtract 5. X less than or greater than or equal to -2. Like you said, X less than or equal to -8. Good. All right. So here's kind of our last, work this one out together, give you some commentary on it. Like I said, you got to decide, which fork are you going down? Okay. And there's no way to know until you solve for the absolute value. Like you might look at it and say, oh, it's a greater than or equal to, so I'm going down the right fork here. You got to be careful here. The first thing to do is to subtract 3 from both sides. -2 absolute value, 3x minus 1 greater than or equal to -10. Okay. Then you divide by -2, but what does that do? Well, it flips the inequality. Okay. And when you flip it, you have to make sure that, now, well, is it the left or the right? And it's based on this moment in time. It's not based on, where you were, it's based on where you are right here. So now you're like, okay, this is back to the one that we were doing in the beginning, right? It's not that it's in terms of like, let me put that back. We're now going down the one where we did the first part of the day, which is you have to remember, okay, I rewrite it exactly as is, but then I negate the number and put it on the left here. All right. So that's the challenge. The challenge is like when you solve for it, assuming you do that correctly, because it's easy to forget to flip this, then you got to know which one you're going down, and then you solve it from here. You add 1, -4 less than or equal to 3x less than or equal to 6, and then you divide
Divide by 3.
everything. Yeah. Okay. But let's just say you messed up, and you thought this was a greater than. Well, you'll go down, they call it a rabbit hole. I've actually never been down a rabbit hole, but figuratively, I've never literally been down. Figuratively, it's like you get completely the wrong answer. So you got to be really careful here, that which route you're going and why. So that's what you want to take into this week, is when you're seeing this in the classroom. Hopefully you see this. If not, we'll work on something else next time. But that's what you should be thinking, is which fork am I going down for today?
Got it.
All right, so we'll go ahead and